This explainer. Today, we're jumping right into the absolutely fascinating research of Dr. Lara Boyd out at the University of British Columbia. For the longest time, we thought of the human brain as this fixed, rigid organ. But as we're about to see, your brain is actually an incredible adaptable hero. It's capable of stunning physical transformations. It is constantly changing based on what you do, and just as importantly, what you don't do. I'm super excited to guide you through this because once you understand how your brain learns, you can literally reshape your own potential. Think of our agenda today as a sort of treasure map to unlocking your own cognitive potential. We're going to cover 1. Debunking brain myths. 2. 3 ways brains change. 3. Short-term versus long-term. 4. The stroke recovery puzzle. And finally, 5. Build the brain you want. Section 1. Debunking brain myths. Okay, let's dive into this by addressing a major paradigm shift in how we understand human physiology. For decades, the medical community held on to this idea that after you hit puberty, your brain was basically, fully baked, right? We thought the only changes that happened in adulthood were negative ones, like losing brain cells to aging or damage. We even assumed that when you were just sitting around doing nothing, your brain was completely silent. But thanks to MRI technology, we know today that nothing could be further from the truth. Your brain is highly active even when you're resting. And more importantly, your daily behaviors are constantly changing your brain, no matter how old you are. So, the crucial point is this foundational concept called neuroplasticity. Basically, every single time you learn a new fact or master a new skill, you are physically changing your brain. It's plastic, it's moldable, it is constantly reorganizing itself based on your experiences. Section 2. 3 ways brains change. Now, you might be wondering, how does this incredible reorganization actually happen? Well, it's not magic, it's biology. To make the heavy neuroscience highly digestible for us, we can break it down into a simple rule of 3. Your brain changes chemically, structurally, and functionally. Let's look at the first one. First up, chemical changes. Your brain works by transferring chemical signals between brain cells, or neurons. To support learning, your brain can rapidly dial up the concentration of these chemical signals. Because this happens in an absolute flash, chemical changes are the primary driver behind your short-term memory, or that immediate improvement you feel when you're first practicing a new motor skill. The second way your brain changes is structural. During learning, the brain actually alters the physical connections between your neurons. Now, because we're talking about changing the literal physical architecture of the organ, this takes more time than a quick chemical spike. But these structural changes are absolutely necessary to support long-term memory and lasting skill improvement. And this brilliantly illustrates just how dramatic these structural changes can be in the real world. Think about people who read Braille. They actually have physically larger hand sensory areas in their brains. Or take your dominant hand. If you're right-handed, the motor region on the left side of your brain is literally larger. But my absolute favorite example from Dr. Boyd's research involves London taxi drivers. To get their license, they have to memorize this insanely complex map of London streets. Well, MRI scans show they develop larger brain regions entirely devoted to spatial and mapping memories. Their brains physically grow to accommodate the skill. No way, right? The third and final way the brain changes is functional. Basically, as you use a specific brain region over and over, it becomes increasingly excitable and easier to trigger again. As these areas get more excitable, the brain shifts how and when they're activated. When you learn something deeply, whole networks of brain activity literally shift and change together to make that behavior completely seamless. Section 3, short-term versus long-term. Alright, let's talk about the frustrating reality we've all faced when trying to learn a new motor skill. Think about trying to play the piano or maybe trying to juggle for the first time. We've all been there, right? You practice, you get better over a single afternoon, and you think to yourself, I've totally got this. But then you wake up the next day, try it again, and nothing. All those improvements from yesterday seem completely gone. Why on earth does that happen? The answer lies in the memory disconnect between our chemical and structural changes. In the short term, during that first practice session, your brain was easily able to bump up the chemical signaling. You felt like a master. But chemical changes just don't last. A single practice session didn't trigger the actual physical structural changes needed for true mastery. Long-term memories take time and consistent effort. What you see in the short term does not reflect true, lasting learning. Section 4, the stroke recovery puzzle. Now, let's pivot to a much more serious application of this research. We've talked about hobbies, but what happens when the brain is severely damaged? So, stroke has dropped the 4th leading cause of death in the US. Sounds like great news, right? Well, it's only because we've gotten so much better at keeping people alive after a severe stroke. The actual number of strokes hasn't declined. The result? Stroke is now the #1 leading cause of long-term disability in adults worldwide. It's an enormous unsolved societal problem, and traditional therapies often just fail to help the brain fully recover. Researchers like Dr. Boyd have developed amazing therapies using robotics and brain stimulation to prime the brain to learn again. But there's a massive limitation here. Neuroplasticity is incredibly variable. Every single human brain reacts differently. A dose of practice that works wonders for one stroke patient might do absolutely nothing for another. But by studying this variability, researchers discovered a really powerful counterintuitive truth. Listen, there is no magic neuroplasticity drug. the absolute best driver of change in your brain is your own behavior. Dr. Boyd found that increased struggle during practice is actually a good thing. It biologically leads to greater structural change in the brain. You have to embrace the struggle, because that exact difficulty is what signals your brain to build new physical structures. You literally have to do the work. Section 5, build the brain you want. Let's move to and see how this builds into everyday applications for you and me. First off, we need to shatter the popular 10,000 hours myth. You know the one, the idea that there's a single recipe of 10,000 hours to master anything. Because our brains are completely uniquely shaped, we require personalized learning. Dr. Boyd's research uses brain biomarkers to match therapies to patients, kind of like how doctors use personalized medicine in cancer treatments. For our daily lives, it means you have to study exactly how you personally learn best. So here are your core actionable takeaways. Number 1, your behavior is the primary driver of change. Number 2, and this is a really critical warning, neuroplasticity works both ways. It's amazing when you're refining a new skill, but if you aren't careful, your brain's plasticity will aggressively hardwire bad habits, drug addictions, or even chronic pain. You must be intentional, repeat healthy behaviors, and aggressively break the habits that aren't serving you. Look, when you step away from this explainer today, your brain will not be the same as when you started. It has physically changed just by processing this information. What you do, what you encounter, and what you experience, and equally, what you choose not to do, is constantly shaping the physical structure of your brain. You are absolutely in the driver's seat of your own cognitive potential. By embracing the struggle of learning and being mindful of the habits you practice, you can harness this neuroplasticity to your advantage. Don't just let your brain be shaped passively by the world around you. Go out and intentionally build the brain you want. So, what new challenge are you going to feed your brain tomorrow? Thanks so much for learning with me today.